How long does it take a car to travel 50 meters if it accelerates from rest at a constant rate at 3 meters per second? So initial velocity is gonna be this, and distance is gonna be this, and we can find the acceleration is gonna be 3 meters per second. So we are going to apply this equation, and this is gonna be 0, so this is gonna be this. So we can find this. So the time is gonna be 6 seconds. What's the acceleration of car A during the interval between t0 and t70 seconds? How far did car A travel between t0 and t70 seconds? How many seconds after t0 did it take from car A to catch up with car B? So firstly, we are going to find the acceleration. This is what the question asked. So also in this graph, the slope is gonna be velocity, and this point is gonna be this, and you can find this point. So slope is gonna be rise over run, so you can find 1 meter per second is gonna be the slope. So this is gonna be the answer of the first question. And you can find the area of this graph is gonna be the distance. So the answer of the second question is gonna be 2,450 meters, and we are going to find the answer of the third question. So car B travels at a constant speed of 40 meters per second. So the distance is gonna be 40 times, and the distance car A travels is 1/2 times acceleration times t square. So this is car A, and this is gonna be car B, and this is gonna be car A. So the cars met when they travel the same distance. So this is gonna be called this. So the time is gonna be 40 seconds. 8 seconds. 8 seconds is gonna be the answer of the third question. A metal box is located on a table in a factory. The box has a weight of 32 Newton, and the machine pushes down on the box with a force of 20 Newton. What's the normal force on the box? So this is the table, and this is the box having 32 newtons weight. The box's weight is gonna be 32 newton, and the force is gonna be 20 newton, and we are going to push it down this box. And so the normal force is gonna be 52 newtons. So the normal force on the box is 52 newton. A wagon is accelerating at a rate of 3 meters per second. If the net force on the wagon is doubled and the mass is tripled, what's the acceleration? Acceleration is gonna be 3 meters per second, and we are going to apply this to this equation. So we are going to arrange this equation in terms of acceleration. So the acceleration of the wagon is going to be 2 meters per second. The graph shows the net force F is in Newton exerted on a 6 kilogram block as a function of time in t seconds. What's the acceleration of the block at t 6 seconds? So we are gonna be find the momentum, and we can use this equation. So the acceleration is going to be 2 meters per second. A baseball player bunts a ball by holding the bat loosely. The momentum of the bat before the collision is 18 units. The momentum of the ball is 40 units before the collision and 10 units after the collision. What's the momentum of the bat after the collision? So this is going to be our bat, and this is going to be the ball. we are going to find this equation. So 8 units, and you can solve this problem by using this. So the answer is gonna be 30 units. This is gonna be the answer. The graph shows the force versus time for an object. What's the impulse delivered by the force graph in the graph between t0 and t4? If the mass of the object is 10 kg and it has a velocity of 4 meters per second and 3 seconds, what's its velocity of 4 seconds? In the first time graph, the area is the impulse. So we are going to find this. So we are going to find this area and this area. So this is gonna be the first answer of the first question, and we are going to find the answer of second question. So the answer of the second question is going to be 4.4 meters per second. This is going to be the answer. A 60-kilogram student goes on a ride at an amusement park that spins quickly. Then the floor drops out. If the ride has a radius of 3 meters and makes 10 revolutions in 3 seconds, what's the centripetal force in Newton acting on the student? So we are going to find these. We can find these values, and the centripetal force is gonna be this, and we are going to apply these to this equation. And we can find this velocity by using this equation. So we are going to apply this to the velocity. So we can find the final value of 80 pi squared. So the centripetal force acting on the student is gonna be 80 pi squared Newton. The mass of Mars is 6.42 times 10 power 23 kilogram and its radius is 3.37 times 10 power 6 meter. What's the ratio of its gravitational acceleration on the surface of Mars to that on the surface of Earth? So we are going to apply this equation. So So the answer of this question is going to be 3.77 meter per second. A satellite is orbiting Earth at an altitude that's equal to the radius of the planet. The gravitational force exerted on the satellite by the planet is F. The satellite is when brought down to the Earth's surface. What's the new gravitational force exerted on the satellite? So this is gonna be the Earth, and this is radius and surface is here. Satellite is in here. So we can apply this equation. And we are going to apply this to this on the Earth's surface. So the first is going to on the Earth's surface means the radius gonna be 1/2r. So the force on the Earth is gonna be 4F. So the answer is gonna be 4F.